Welcome to Web App Observability, understanding the client-side experience. In the beginning, there was a server. You may have called it a mainframe. Users connected to it and asked it about data. We could check that the server was running by looking in the server room. Was it on fire? No, things are okay. And it was good. Then, some clever people figured out how to send data in a format called HTML and taught our servers to speak it. Now, users could see data without a constant connection or this thing called a browser. And users could do more of the work while presenting the data. And data could link to other data in a web that we could explore endlessly. And it was good. We needed more servers, lots of servers. We couldn't look at all of them anymore. Some clever people figured out how to monitor them so that we didn't have to look at them anymore to know if they were on fire. And it was good. Then other clever people figured out how to make the browsers smart to do more of the work of the server. Users loved that the web felt interactive. We loved that we needed fewer servers, but it was not good. We could monitor our servers, but not our users. And now the users would catch fire, or their browsers would. They didn't care if our servers worked. The system looked broken, but we didn't know. Hi, everybody. My name's Todd Gardner. I am the CEO and founder of a company called Request Metrics, but I build lots of things with software, usually about client-side monitoring and observability. I've been working in this space a very long time. And that was my cold open description of this problem that we are fighting here, is that we have great tooling. We have lots of great practices around understanding how our servers fail, but we don't always understand how our clients fail. And so this is a talk where we're going to go through a bunch of things around how do we understand how we look at the data that we can get off of the end user's browser to understand what kind of experience are they having and how to make it better. Like I said, my name is Todd Gardner. I spend most of my time on a thing called Request Metrics. Generally, my work over the last 10 years has come down to like these 4 key things. I work in logging, monitoring, alerting, and lately we have this new great word called observability. And I just love how this acronym falls together. It really makes a joke of my career overall. But observability, this is the thing that everybody's talking about these days. And it's not clear what the definition of it is. If I asked 10 different practitioners in this space what it means, I think I would get 10 slightly different answers. So just to level set everybody's expectations, when I say observability, I'm talking at a super high general level, your ability to answer questions about the running system. So not attaching debuggers, not adding new metrics, not deploying a new monitoring agent, but it's your ability right now to answer questions. But that's usually where like a DevOps-y kind of person would leave this definition. But I'm a client-side person. I focus very much on the users and the end user experience. And so I think that's an important distinction to add here around observability, is the reason that we're doing any of this is to improve those end user experiences. When you're building a monitor, or when you're trying to monitor a server-side application or a cloud application or a microservice application, you have the packages that you deploy to each box, and they run, they do their job, and you can monitor them. And if something goes wrong, you know that something really went wrong. Like that service, that server, that cloud instance really had that problem. But when we deploy things to the client, we're not deploying different things to everyone. We're deploying one package that is entirely responsible for that one user's experience. And we're deploying lots of those packages, every one of them hypothetically identical to lots and lots of different users. The trouble is that even though we've deployed this seemingly perfect application out to the users, it's going to break in unexpected ways. Mainly because users can be terrible and they'll do weird things. They're going to have browser extensions. They're going to be browsing your site on a Samsung refrigerator. They're going to be on a crappy internet connection that injects advertisements into every page they visit. They're going to do terrible things that we can't all predict. And so in order to ensure that our users have the best possible experience, and therefore our site, our website, our business is successful, we need to know what's happening, collectively aggregate all that data together so that we can figure out what's going to happen. But something that is very important, one of the most common problems that people run into as they're starting to think about a monitoring or observability or data gathering effort is that they want to go from nothing to perfect in one go. And that cannot happen. There is no vendor that you can go to and say, give me observability. There is no one magic playbook to run because it's a meld of technology and people and process together to have the data that you need and have the maturity to look at it and understand it and correlate it and make the right actions. So I'm going to tell you a little bit of a story, a journey that we're going to take over the course of 20 years of the web maturing into how we've approached observability and how we've layered it on step by step to get better data. So let's think back, way back to the 2000s. Now, I'm in my office, in my home, so I can't really see any of you. This is usually when I try and judge, am I the oldest person in the room? And sometimes I am. And if that's the case here and y'all are a bunch of kids, that's cool, but this might go way over your head. Because back in the 2000s, I looked like this. You'll notice that I didn't have really any hair on the bottom of my face, and I had a lot of hair on the top of my face. But I was not at all drinking alcoholic beverages at college. The web looked a lot like this. This was GeoCities, which was where I cut my teeth on the web, building GeoCity sites, which was cool. We used obnoxious fonts and really pixelated graphics, and every site was constantly under construction. And the thing that we needed to add here was web analytics. That was the extent of the monitoring. And in the very early web analytics really just took the form of a little visit counter, which was, just a number of visitors. Your Spotify library. Which was just a number of visitors who had visited the site since the last time you had reset it. It was not very good data. But we refined that and we got better. And once we can actually count the users and some demographics about them, we can find really interesting statistics about it. So here's a little correlation. So if we're building a healthcare system, for example, one of the first kinds of data that we would want to capture is just hey, how many people are born and how many people die and what age and some basic demographics around them. And that data can look really kind of cool and interesting. So here's some data from Canada from quite a while ago, but it was matching up birth and death rate or death by age across male and females by age. And so we see way back at 0, there's some complications that happen at birth, but then everything normalizes out and people are healthy. And then mysteriously, right around the age 20, there's this dispersal where men are way more likely to die than women. Maybe because men are doing dumb things to impress women. And that continues for several years before they starts, tying back together all the way up until we hit, the ultimate termination point. But how do we gather this sort of data from a web application? Well, way back in the day, this is what it looked like, is we would put an image tag on the page. And this would serve a 1-by-1 transparent pixel from this endpoint. So we're loading an image, but that image isn't visible to the user. But simply by requesting that image, we would get a bunch of cool data through the magic of what HTTP does. So we'd get like the user's language. We'd get what page they were on. We'd get their user agent string, which would include things like their browser and their device and sometimes plugins and other things. And we'd also get their IP address, which would allow us to do things like know where they are geographically, and maybe what network provider they're on, and those sort of things. And that was really great information. As the web matured and we started using more and more JavaScript on the web, we could do this in a different way. And rather than just requesting an image, we would use JavaScript to place an analytics agent onto the page that we could gather a lot more information. And it looked something like this. This is generic, but like if you've ever used something like a Google Analytics or any of those sort of tools, this should look very, very familiar. We start out with this obnoxiously long minified string of JavaScript that largely all it's doing is setting up a asynchronous loader of the real library to come down later. And then we're setting it up to install or configure or start the page view or whatever this particular library will call it, with some sort of user token and configuration. And by doing it this way, analytics tools could get a whole lot more information. Things like how big the user's display was, how big their window was, what time zone they're in. Sometimes on browsers, we can even get what kind of network connection they're on, where they came from, like what other page, how long they're spending on the page, what they're clicking on, how they're scrolling, all kinds of cool interaction stuff that we can use to learn how well is our site doing the things that we built it to do. And that data, once we can collect it, looks like this. So here's a couple examples. This is Google Analytics, which is, the 800-pound gorilla in space. If you do analytics, chances are you've used this tool at one point. Here's a listing of like number of users and number of sessions and number of visits based on how they got to our site. So did they come in through Google? Did they come in through Bing? Did they come in through something else? And it's fairly high level. We can't really drill too far in on this. Here's another point of view. This is a top level analytics dashboard from Request Metrics, where we're showing like a geographic report along with that same session and user data, but various other things like where they landed and how many interactions they have. Or here's another view where we're showing like traffic sources, breaking things down by where they came from, how many users, that sort of thing, with a chart, that sort of stuff. And there's lots and lots of analytics tools out there that will have various visualizations. Now, in the 2000s, that's largely what we did. We had analytics. We knew how the web, how users were moving through it, and we could optimize. The web wasn't all that complicated yet. And so we didn't need to worry about the end users getting their browsers to catch on fire. But in the 2010s, a lot changed. Now, for me, this was the start of a major transformation as the hair started moving from the top of my head, was getting much thinner, and moving around to the bottom. This is a photo of one of my greatest regrets in life. I was out antiquing, going to like antique stores, and I ran across this thing, which was a 4-foot tall replica of the Lego pirate captain. And it was glorious. And it was $200. And Todd at the time did not think blowing $200 on a giant piece of plastic was wise. And so I just took a selfie with it and moved on. And every day since, I have regretted not owning that 4-foot tall Lego pirate for only $200. How cool would that have been? The web got way more interactive in this time. How many of you might remember, I can't ask because I can't see you raise your hands. Many of you might remember Gmail, the first Gmail, back when it looked like this. This was one of the first interactive apps that we had, where it wasn't just text and images on a page. It was, I could click on something and see new data without it reloading. I could change the status of things. It was an application that I didn't have to install on my computer. I didn't need to install Outlook or Thunderbird or whatever in order to read email. I didn't have to configure things. And it was awesome. But with this came a lot of JavaScript, and usually pretty bad JavaScript that didn't work super good. And so the first thing that a lot of these organizations needed to do is implement error reporting. We needed to be able to triage and stabilize when things went wrong, because they would go wrong a lot. And so what's an example? Like how do things go wrong? Well, so here is a super common bit of code that a lot of sites have. This is an early recommendation pattern from a tool called Stripe, which is payment transactions. And this is it's not how they recommend you do it anymore, but this was one of their guidance paths in their docs a few years ago. And so in this, we have a script tag where we're loading Stripe's library from js.stripe.com. And then in the next script, or in the next tag, we're configuring it with our key. But there is a major error in this code that is not entirely obvious, but if you take this and you put it in production, between 1% and 3% of your users will run into an error here. And that error is going to be manifested as reference error. Stripe is not defined. Why? Well, those two scripts are indirectly coupled together. The second one depends on the first one, but there's nothing that guarantees the first one will succeed. And in fact, because it's hosted on a CDN, and because it could be a new SSL negotiation, and because it's a third party, any number of things could cause that script to fail to load. The browser could have a hiccup on its network connection and can't do a DNS lookup. The Stripe team might have done a misconfiguration and deployed a bad script. There could be any number of network blips that happen, especially on a mobile device, that cause that script to fail. And then as soon as the next script loads, Stripe is not defined and we cannot call configure on it. And the whole page, presumably a checkout page, is left in a weird state where I don't entirely know where the credit card details might go. Have we tested it? Maybe not. We should really know when this sort of thing happens. So how would we even know? How do we know that these sort of errors happen? Because they're not happening in our data centers where we have any kind of control. They're happening out in that end user's browser. And so when it blows up, that data is remote to us, and we need a way to get it back. Here's a very naive example. Not all the code examples I'm going to show you are not production ready. Do not take this and implement them. There's tons of subtle operational problems with it. But at a high level, this is how that would work. We can listen to a top level error event. So window.error. And when an error happens, we could post that off to an endpoint back on our services where we control it. We can aggregate it. We could stick it in a database somewhere. And we just stringify that error event and post it back to our system. Now, this solves some of the problem, but unfortunately, errors in JavaScript specifically kind of suck. And this will only report about 40 to 60% of the errors you experience. Because there's a whole bunch of other kinds of things that logically developers consider an error, but for whatever reason are not considered an error with this code. Things like if you call console.error, that wouldn't get sent here. If you have a promise that gets globally rejected, that doesn't get sent here. If you have a network call that comes back as a 500 something, that doesn't get sent here. Plus, there's a bunch of extra things that we don't get yet. It's like understanding your source maps. So translating a bizarre stack trace from E is undefined to hey, here's your TypeScript or Blazor code or whatever code that was actually running. Plus context about what they were doing and metadata and stuff. So there's tons of extra data that you would actually need about errors to make them meaningful, because JavaScript errors tend to suck. But if you were to get that data, you could get errors that look much more like this. Here's an example from a tool called Track.js, where here's an error. Request failed with a status code of 400, happened immediately before a console log. On the right-hand side, we see the actual code that was running with comments and a bunch of cool stuff, so that this is a way that we can much easier understand that, oh, there's a problem on Android Chrome Mobile on this particular application, and here's how we would go about recreating it. And so with a tool like this, or this data in your own system, now you can start to understand what are the issues your end users are running into and which ones are stopping things, which ones affect so many people that you absolutely need to fix. And that's really important because so many so many developers wait to see what the users think. Like they wait to hear something. And that doesn't happen. Like for every time you'll hear that, oh, the site's broken from the end user because they called you or emailed you or complained about you on Twitter, there's probably 100 or 1,000 other people that it happened to and just decided to not do you that favor of telling you and just move on. And so it's really important that you know that these things happen. But errors are not the only thing that can go wrong, because sometimes it's not that a website is breaking overtly, it's that it's getting slow and frustrating to use, and so the users are abandoning it. And so this isn't about like an acute issue, it's more about chronic issues. Is the web page getting slow or getting slower? And there's some complexity in how we would go about measuring this. In the old web, we would measure this with a concept called page load, which was pretty easy to understand. When the user would click on a link, the browser would make a request for the HTML, and the HTML would come back from the server and it would start drawing it. It would start rendering it bit by bit in order. And so this is like a slideshow of how it would load over time as the end user would see it. This is geocities.com. And we would measure performance by just recording the time between start, when the user clicked on the link or whatever, and this JavaScript event called load, which would fire when the page was done rendering. And that was great. We could measure it. It was one number. It was easy. But as the web got complicated, developers started cheating. And they started introducing lazy loading patterns. Because sometimes there'd be parts of the web, particularly things that we would use JavaScript to load asynchronously, that would be slow. And we wouldn't want to, get in the way. But that messed up all of our page load or our performance loading algorithm, because now the load event would fire early and a bunch of other stuff would load after the fact. And so we could trick our metrics. We could mess with them by creating a site that was an empty HTML page, and load would fire almost instantly. But that page was just full of annoying spinners that over time would bleep new content into place. And so our metrics would all report, hey, the site's super fast. But the users would be like, hey, your site sucks. And there was just this disconnect. So we needed new ways of measuring performance. So a few years ago, Google tried to solve this problem with a new set of performance metrics called the Core Web Vitals that don't just measure one thing. There's not one measure of speed, because a site can feel slow in a lot of different ways. Users perceive performance in different ways. And so we're trying to measure them differently. So here's like npr.org, and here's like the film strip of it loading. And rather than just measuring from start to load, which doesn't capture a lot of the async content that comes in, we measure a bunch of different milestones along the way. So here's that same axis where we're measuring like that load time. And so from start until the first metric that we stop at is time to first byte, TTFB. And it's measuring how long does it take your server, your service, your endpoint, your CDN, your whatever, how long does it take to get the first byte out the door? It's measuring how fast your infrastructure can figure out what it's doing. Then the next stop is the first contentful paint, or FCP. The first contentful paint is when the browser has enough data to render something, to render the header, to change the background image, to do something. And this is an important user metric, because this is the first time the user feels like they will actually get what they clicked on. Up until this point, the user is just staring at a white screen and getting frustrated if that takes too long. Then we measure to largest contentful paint, or LCP. Now, this is a measure of when the user feels like the site is functionally complete. Now, we can't just tell Google when our site is functionally complete, because rightly, it doesn't trust us, and we would lie to it. And so rather than just saying, hey, this is the most important part of the site, measure until this is loaded, it just says, hey, by pixel area, how the biggest thing on your site, when did that load? And if we're following good user experience and design principles, the biggest thing on the site should probably be the most important thing, the thing that they came for. And so we're measuring how long until that takes. Now, we're not waiting until it's done, because asynchronous, lazy loaded content has kind of ruined that. And so we can't really measure that for performance anymore. But this isn't the only axis that we measure, because the user can also perceive slowness in other dimensions. So this is a measure called cumulative layout shift, or as your site is loading, how much is it moving around? So if you have something asynchronously loading in and the box that it's going to be in starts really small and then pops open big, like annoying advertisements or stuff like that, it creates a layout shift where all of the other elements have to move around in order to accommodate that new size. And that's frustrating. Users don't like that. And so if your site moves around too much, you're going to get a bad CLS score. The third and final dimension is around interactions. And there's two different metrics that we measure here. First, the first input delay. So this is measuring from the time the user first clicks on something or scrolls or types or does something, some interaction. How long does it take the browser to figure out what to do with that event? Not how long your code takes to run, but how long does it take the browser to figure out, where do I route this event to? Which JavaScript might be listening to this? And it's a measure of, are you sending an appropriate amount of JavaScript down to the user? And is the user interacting when the site is actually ready? So if the site is not ready yet, because you're sending an obnoxious amount of JavaScript down over the wire, then when the user clicks, the browser's still figuring it out, it's still parsing your JavaScript, and that score is going to be poor. If you need to send huge amounts of JavaScript, you need to put like loading spinners or something to stop the user from interacting. Or you just need to send a more appropriate amount of JavaScript for the device types you're targeting. The second measure here is interaction to next paint. This one's a little bit more experimental, but it's a really cool metric. And it's an ongoing thing of every time the user interacts, how long does it take between that interaction and some paint event? So clicking on a button and that button disables, or doing an action and a loading spinner shows up. Giving the user feedback that your site has recognized that action and will do something about it later. And this is a cumulative metric, so it's adding all of these up over the lifetime of the page. Now, these metrics are all defined by Google, along with what the ranges Google thinks are acceptable or not. But capturing them is a little weird. So in order to produce all these different kinds of metrics, there's a new top-level object in the browser called the Performance Observer. Now, Performance Observer is broadly supported. However, the individual metrics may not be supported by all browsers. A lot of the performance-specific metrics are still limited to just Google's link-based browsers. However, it is the 800-pound gorilla. It dominates the space. And so even just using that, we still get a really good sample size. But here's how we use that. So we create a new Performance Observer. And every time the Performance Observer will go off, we just take the list of metrics that it has found, and we send it off to some sort of performance endpoint. And then we list off at o.observe, what are the things that we care about? And we would list off all of the metrics that we want to track along the way. Now, there's dozens and dozens of these. I put a few of them here that are interesting from the core Web Vitals perspective. How does this data actually look? Well, the most common thing that you might be familiar with is how the data is presented here. This is a Google Lighthouse report. Which would also be available from like Google PageSpeed Insights is like a wrapper around that as well. And here we're showing like a performance score. So you opened up Google Chrome and you ran a performance audit and it gave you this report and it said, hey, your performance is great. And it shows you the individual metrics that came into this. And a lot of those individual metrics are those core Web Vitals. But this is just one data point. This is how fast that page loaded for you that one time, given how the state of the universe was at that moment. But when we're talking about end users, it's not just one data point, it's hundreds or thousands or millions of data points. And so that core Web Vitals, the core Web Vitals that you would come around, that core Web Vital data can also be presented in aggregate. So here's a report of how a lot of different core Web Vital data around largest contentful paint would be presented across in this case, 19,000 page views over a course of a couple of weeks. And how many people had good scores, how many people had bad scores, how many people had really bad scores. Now, one thing to point out here is that because we are talking about so much data, it's not about there being a single coalescing number. It's about understanding percentiles. Now, if I can channel your elementary school math class for a second and to try and understand percentiles. If we take all of the performance data, so every single person's, say, largest contentful paint score over a period of time, and we sort it from fastest to slowest, and we start going through that list, once we get halfway through that list, that value that is halfway through, that's the median score. That's the 50th percentile. That's to say half of your users have this score or better. Now, if we keep going till we get to 75% of your user data, that's the P75, the 75th percentile. And that's a really important metric because that's the metric that Google uses to judge your site. That's the metric that will often be the single metric that we talk about. So in this particular report, when we say the 75th percentile is 1.3 seconds, that's a really important thing to point out because if that's a bad score, according to Google, Google will penalize this site in search rankings, saying that it is slow. Now, sometimes you also want to know, like, what's the worst score? And so if we keep going down that list till we have 95% of the data, that's usually what we consider the worst score. Sometimes if you have a whole lot of data, you might go to the 99th percentile to understand what the worst score is. Some of you are probably like, but Todd, like, wouldn't the worst score just be like the last thing in the list, like the P100? And no, only because the web sucks sometimes. And there's tons and tons of noise. And so if you look at the absolute worst scores that you get, it will be measured in years. It'll be like fake data, bad data, data from bots, data that got mangled in transmission. It won't be at all interesting or correct. And so usually we lop off that last percentage. We lop off that last percentage so that we can understand stuff. Here's how another way that like Core Web Vitals would often be presented in a lot of different tools as these bars. So you'll see these in like PageSpeed Insights and lots of different places where we'll show like here's the number of people, the relative size of people that had good scores, okay scores, and bad scores. And where the P75 falls is really, really important. Okay, so there's a couple of questions that I want to address. Are there any other tools or services you would recommend to monitor performance? Yes, I mean, absolutely. I'm totally biased. I would recommend you try out Request Metrics because that's the thing that I work on and a lot of stuff like here. Google Lighthouse and PageSpeed Insights are really good for point testing. Also, there's a service called webpagetest.org, which is a little bit more thorough than Google Lighthouse. But again, it's a point testing tool. It's not for like longer term stuff. If you have infinite time and money to solve this issue, kind of the top end of this market is a tool called Speed Curve, where you'll pay like, I don't know, thousands of dollars a month, but like there's lots of cool reports that it can do as well. And then somebody else asked for a thing about Request Metric, discount for Request Metrics. And yes, absolutely. We'll talk about that in a second. But I want to address, like, it's perfect timing for that question around other tools, because this is an important distinction in how we monitor, where we monitor from, is synthetic testing versus real user monitoring. It's a question of where do we choose to observe our application from? I'll come back to that in a second. So where do we choose to observe? So if we take the super naive picture of your application. So I've oversimplified all of the server work you do down to those three boxes. And those three boxes ultimately deliver some HTML, some CSS, and some JavaScript out through the cloud to the end user's browser to do something. So if I'm to monitor this very simple architecture, there's three big places I could choose to go from. The first would be operational monitoring. So I put agents on those pages and I record how long does it take for things to get out the wire? How long do my endpoints respond? How long does my database respond? Those sort of things. And it's measuring my system. It's measuring the things that I have complete control over. But it's not reflective of what the user is seeing because there's all kinds of magic that happens in that transition. Tons of problems around DNS and load balancing and air handling and network transmission, tons of things that happen there that this sort of operational monitoring misses. So we can get some of that with an idea called synthetic monitoring. And this is what like Google Lighthouse and PageSpeed Insights and web page tests are, this kind of data, where we've created a robot out on the internet somewhere. And periodically we've told the robot, go to my web page and click this and click that and do that, and then tell me what the performance is of that experience. And it's interesting because we get very uniform data because we're doing the same thing every time, and we're getting some of the information about network transmissions and stuff like that because we're really accessing it from a place out on the internet. And so that's real data. It's just not our users' data. Or the third place that we can look at is we could put an agent in the user's browser, usually with JavaScript, not like a Chrome plugin or anything like that, like a bit of JavaScript to pull their actual experience data of how the users have interacted with our system. And like that's like the gold standard right there, you know? That's the data that we actually want. Unfortunately, this is the problem with it, is signal and noise, is that operational data has a lot of that. It's very low noise. If something goes wrong in our operational data, it probably really went wrong. Like it's not like a 500 error is going to be fixed somewhere along that transition. However, on the opposite end, your API could return a perfectly good response that blows up before it gets to the user due to somebody messing with it in line. And so understanding the real user data is our goal, but there's so much noise in it that we don't always understand what's important. And so if you were to go down this journey of gathering data from your real users, filtering that data becomes supremely important. It's about understanding what kind of data you want. So not every person who hits your site, who hits your app, is probably relevant to you. You're not trying to ensure that every single one of them has the experience, has the perfect experience. And if they don't wake you up in the middle of the night, you're trying to understand, are my target users having a good experience? And who those target users are will depend on your application. But for example, maybe you're only targeting evergreen browsers. So browsers who have the latest version or latest -1. And maybe you're targeting people who have good network connections. Like maybe you're targeting people in a desktop kind of environment. So nobody on a 3G or lower connection. And maybe there's some geographic things. Maybe you're targeting people in Europe. Maybe you're targeting people in North America. And so if you're doing that, and then you get a bunch of people who visit you from, say, outer Mongolia, that's probably not relevant for you. And so if they have a bad performance experience, you can throw that data away. And so using that allows you to really focus in on what you're after. Before we move on to that, I do want to address the question of how does web app observability impact Google's judgment of a website's user experience? So in a couple of different ways. So the the user experience score that Google generates as part of when it's crawling your site goes in as a page rank factor. Now, that is Google's secret sauce, and nobody really knows outside of Google how that algorithm completely works. However, as of March of last year, so over 12 months ago, both the core web vitals, all of the core web vitals have become influencing factors. So if you have scores that are improve or poor according to their rankings, they have said that that influences your search or your search rankings. Now, it's all anecdotal. People have said that they have had their search rankings fall and then been improved over the course of time since then. Other parts of observability, like errors, have not been signaled that they are ranking factors. So like a JavaScript error should not decrease your ranking, mainly because there's lots and lots of JavaScript errors, and not all of them are user impacting. I'll talk about Blazor at the end. All right. Website integrity is another important aspect of this. Because, all right, so errors aside, performance aside, sometimes people are just trying to attack our stuff and give our users a bad experience because they're trying to steal data from either them or me or like you, the owner. And so there's a couple of different ways that can happen. One of the most common, something that we've been fighting for as long as I've been a web developer, is cross-site scripting. So, those annoying testers taking a string like this and pasting it into every single input of our web app and trying to see if any of those alerts pop up. And they're not just trying to be irritating. Ultimately, if they can get one of these things to go in, they can inject all kinds of malicious scripts that could install a keylogger to pull credit card information. They could session jack the user and like grab other data from your systems. They could mine Bitcoin and just consume resources of the user and the planet to their own financial aims. Lately, we've also seen a huge increase in supply chain attacks. So especially in JavaScript land. So you're a web developer, you're going about your day and you're like, hey, I want some cool icons for my web app. And so you go npm install Ionic icon or whatever, and you get those icons. How many of you actually go through and do a source code review of that thing you just pulled down? Almost nobody, right? Like that's just not the culture of web development in most places. But we really should. We really, really should, because Ionic icon, along with a ton of other packages, were part of this exploit called icon burst, where these were real packages that did real things that people thought were valuable, but they were slight typos or variations on names or that sort of thing. And they also installed keyloggers or other sort of vulnerabilities trying to get credit card numbers off of pages. And so these are really tricky to find because this isn't like some third-party JavaScript running. This is our JavaScript doing something malicious that we didn't know about. And so what's the way that we would protect this? So the most common or the authoritative way to protect this, if you are in a high security kind of environment, is content security policy. So this is a set of HTTP header rules that we would use to control where you can load JavaScript from and where you can't, and all of those sort of things. And it's a really rock solid way of doing it. Unfortunately, because of a bunch of process reasons, it ends up not being very broadly adopted. It tends to slow down a lot of development organizations because producing an authoritative list of what JavaScript you're going to allow is really hard to do. So I've been thinking about like a different way. I have this really good hammer that I like to use called JavaScript. And so if I have a problem, I tend to try and bang that problem into submission with more JavaScript. So what if we could do that same kind of job and understand what JavaScript is running through more JavaScript? And I can do this through something called the Performance API. The Performance API allows us to essentially get a JSON version of the Chrome DevTool network tab and do all kinds of interesting things with it. So here's an example where I'm grabbing all of the entries and I'm looking for JavaScript tags. And I can just list off all of those JavaScript tags and send them back to my server, or I could do interesting things with it. I could look them up. I could see what's new, what's changing, that sort of thing. And so hypothetically, this doesn't exist yet, but it will very soon. Something like this could exist, where you list off, here's the domains you've trusted to load JavaScript, and maybe a risk profile. Is this known malware domain? How long ago was it registered? How many times does it run? A bunch of interesting things that you could use to guarantee that this code that you're running is the code you intended to run. Now we are on to the 2020s. What's going to happen in our current era, which we're just getting started with, but there's so much going on. Well, right now, the hair has fully moved from the top of my head down to the bottom, and kind of completing my adulthood transformation. And the web is amazing. The web can do anything. So if you're out on GitHub and you're looking at a repo and you're like, oh, I don't like that bit, I want to change that thing, and you change github.com to github.dev, it opens up a full VS Code environment right there in the web that you can then make the change and create a PR and do everything without setting up any sort of local dev environment. And that is amazing. but it's also terrifying for the amount of JavaScript code that went into that. And so we're approaching this idea of client-side observability, holistic collaboration, like pulling together all of this kind of data to better understand what we're doing. And why are we doing it? We're ultimately doing it to improve the end user experience. And so that's why it's so important to include this kind of data in any sort of observability effort, because this is the goal, is to actually look at the users and make their experiences better. And so there's a few levels that we need to go through to get there. Level 0, first thing we need to do, you need to get the data. So there's all this data that we've been talking about sitting out on the end user's device about analytics, errors, performance, security, API calls, tons of stuff. You need to have that data somewhere that you can look at it, report on it, do stuff with it before you can do anything else. The next step, and the step that a lot of organizations right now are struggling with, is sharing the data. It often exists inside of a silo. So the marketing group owns analytics, and the security group owns security, and the user experience groups own performance, and the engineering owns errors, and nobody's sharing that data. And if you can't see the other data, you may as well not have it. You need to be able to correlate that data together, which gets us to this next awesome step, is that if I have that data and I can see that data, now I can do interesting things. So here's a performance example. So here's some performance data over a couple of weeks, and we spot a CLS issue, a commutable layout shift, and a couple of largest contentful paint spikes. Now, if I was to take this data and be like, hey, product manager, I want to spend a couple of hours next iteration, next sprint, next whatever, working on these metrics. They're like, well, why? What do those metrics mean? It's an uphill battle because you're talking to them in technical terms. But what if we were to have that analytics data right there with it? What if we were to be able to say, hey, here's some analytics data, and it looks like there's a correlation between CLS and session time. And it looks like there's a correlation between LCP and bounce rates. And hey, now I can have that conversation where we can say, hey, I think there's an engineering problem that's hurting our bounce rate and session time. I think we can make it better. Let's spend a little time focusing on that. Now that business person is like, heck yeah, those translate to dollars. We can absolutely have that conversation and do that. And so with this sort of correlation, observability data from the client side transforms into something that's way more meaningful. Imagine getting an error like this. 3 API endpoints on your example.com are returning a higher 500 response code than they normally would. That's normal. Lots of tools can do that. But if you correlate that, you could say, and form submissions on the sessions impacted by that are down 75%. Now you have a dollar in priority kind of thing. Now you can make that decision of, is this a drop everything and fix it right now kind of situation? And next, this kind of leads into, how do we predict things? How do we really get in on understanding the significance of our data? And so what if we could do things like, there's this error that we're seeing, and historically it has tended to prevent conversion. So if this starts happening, I expect you to lose 112 conversions, whatever that means to you in terms of dollars, in the next 24 hours if you don't resolve it. And so now we can have these questions where this bug is costing you $12 a second. And now you can prioritize based on what are the things that are costing you real amounts of money. And that's getting into some really weird AI stuff, which we're just dipping our toe into, and there's a lot of excitement about. I did a little bit of this a little while ago. Here's kind of a first wading out into it, where we took some data about API requests and we funneled it out into ChatGPT, and it already can produce really interesting insights. It can point out that hey, there's a bunch of requests happening and they're all for SVG files, and that's kind of weird because that's not normal. And it was true. It was the kind of thing that we can go out and we can discover things that a human couldn't normally have spotted. But all of this world is up to us. It's up to us caring about this, because these are our systems. And it's about more than just the pager rotation or the tech that we're using. It's about our users, and it's about making our systems better for them. And I know all of you care because you spent 45 minutes here with me talking about this. So if I'm to give you one piece of advice, don't try to boil the ocean. You can't do all of this at once. You can't go from 0 to like super high end in one go. Step by step, get the data, share it with others, learn about your client-side environment, and start correlating things to see what's interrelated for you and your ecosystem. If we can do that, it's going to be good. A lot of the things that I think about that I've talked about here are codified in a thing that I'm working on called request metrics. If you're at all interested in that, I'd love to follow up with you more later and show you everything you can do, or you can learn more at requestmetrics.com. This was Web App Observability, understanding the client-side experience. Thank you so much. There's a bunch of questions I haven't had a chance to address yet, but I'd like to. Maybe if there's one of those general rooms that I could jump into afterwards. Is one of those available?
Yes, they are available, but you were the last one to talk, so we have all the time in the world. If you
all
would
the
like
time
to
in the
address
world. All right,
that.
well then let's just go through and talk some more.
All right.
All right, let's see. What were some questions I did not answer? Somebody asked for a discount on request metrics if I'd like to give it. Sure, I'd like to give it. If you sign up for a trial at requestmetrics.com, you're going to get an email that looks like it's coming from me. It's a robot, but it really, like if you respond to it, it really is me. So just respond to that and say, hey, I saw you at this ABP conference. Like that was cool. And we'll work something out.
Oh, perfect. We had a question about Blazor.
Yeah. Blazor, for an example, has a massive initial load time, but Angular lazy loading makes the different aspects of the page load slowly and the main page loads. What is the most important factor? So I actually have a whole thing about this around user perception. The user perceives performance in different ways. And one of the core learnings of that is that there's a lot of psychology around it. And so it's about the value, the perceived value and stress that the user is under when they're loading the page. And it's got to be appropriate for the value that you're delivering. So if you're delivering a high value thing, like let's say you're working in finance and like it's a loan application, or you're working in healthcare and it's like results or something like that. These are high value transactions. And so if there's some additional JavaScript, some additional load time that needs to happen in order to deliver it, mostly the user will wait because they believe that something real needs to happen. There's some great use cases out there where like sometimes web developers intentionally slow down an interaction to slower than it needs to be because it makes it feel more important. Because it's like, oh, I actually calculated this instantly, but I'm going to wait 5 seconds so that the user feels like I'm doing something big and interesting. But the opposite can be true. So if you're delivering pictures of cat GIFs, but you're delivering an obnoxious amount of Blazor to do it, that's probably the wrong tool for the job. Like if ultimately what you're doing is delivering text and images to the DOM, you shouldn't be loading a huge amount of JavaScript. We should be using like progressive enhancement to add the interactivity where we need to. So it's about doing it appropriately. Now, if you are doing it appropriately for what the user is doing, there's lots of tricks around load time and giving them interactions. So like drawing a skeleton of the user interface and having it slowly fill in over time. Those are very good UI patterns that a lot of people are expecting and know what that means. It's a massive initial Angular lazy loading makes the different aspects of the page slower after the main page loads instead. I'm not sure that I successfully answered that whole question. I think part of that was coming in on largest contentful paint. Because at what point the largest element loads on the page might not be immediately. It might be 10 seconds into the load time. And if that's the case where the largest thing takes 10 seconds to load because of whatever async pattern you're using, you're going to have a really, really bad LCP score. So I hope that pattern is not publicly facing so that because Google would hate that. I think I answered that.
All right. We have another one.
There are differences between the habits of e-commerce site and ERP. Which metrics would you pay more attention to? So the metrics themselves, I think, are still interesting. And that touches again on the end, focusing on the end users. So you may not care about what Google's defined measurements of first contentful paint, largest contentful, you might not care what they say are good good, okay, bad. But you should have your own measures of what you think is good, okay, bad, based on your users and how, like, what they're waiting for and their kind of flow. Because there's still interesting measures of, like, how long does it take to get the first thing drawn? How long does it take to get the big thing drawn? How much shifting is happening? These are still real measures of how an end user perceives performance. But you could add your own. So something that's really common is to define your own custom measures and metrics. So for example, Twitter defines like a business metric around time to first tweet. So how long does it take between the first time you've loaded the interface and you've sent the first tweet? That is an important metric for them. And it touches on performance, it touches on usability, it touches on business goals, it touches on a lot of things. And you can define that. There's some tools to define that. If you look again at the performance API, there's the idea of defining marks and measures where you can put different timings in the page load sequence that are important to your flow. And then you can measure those over time by saying, here's how long it is to time to accounting table load or whatever. And then you can try and optimize it from there. The performance is a very subjective thing, very focused on what is important to you and your users. How would you sum up your talk in negotiating performance and security? Okay, summing up the talk. Okay, the first most important thing is to get the data, right? This data doesn't exist in your data center, it exists somewhere else. So you need a way of like pulling in data, whatever that data is. You need some sort of mechanism to get it into your own data store or a service or somewhere where you can see it. Then you need to, the second thing is you need to think about what data is important to you. So do you care about performance? Not everybody actually does. Like if you have a bunch of captive internal users that like, this is the thing that they have to use, a lot of those teams just don't care because there's no alternative. And like, maybe they should care, but not everybody does. Same with security, okay? Some people don't care about security only because the site is so low value that like nobody's going to bother attacking it. Like if I have a static page full of cat GIFs, I don't really care if somebody cross-site scripts it really because it's cat GIFs. But if I'm a bank, if I'm a financial institution, if I'm a government, like you care a whole lot. So you have to do some thinking about like, what are the metrics that are important for you? And then third, once you have a way of getting the data and you decide what data is important, having a way to pull in and summarize that data in a way that you'll actually look at, not in a form of like giant text files or bizarre SQL queries or something like that, in a way that you and your team can digest it and understand when something weird is happening.
And before we wrap up with the last question, I would like to comment on that cat GIFs. I think when someone publishes a website with the cat GIFs, I think they would be happy if the cat GIFs got stolen somehow. Don't you think? I would be happy to see some cat GIFs.
Yeah, they're my cat GIFs. I don't want anybody taking my cat GIFs.
Well, still, I would like to see some. I don't know. Let's hop on to the last question.
Yeah, if you have a website full of cat GIFs, you better post them so she can go see them.
All right. Thank you. And we have Martin. He's asking if there's a technology to revert the process.
From the top, is there to revert the process? Being a middle-aged man, my social media is full of all kinds of pharmaceuticals and LED-based products and whatnot that promise to do just that. I don't believe there is anything credible. However, if you are also suffering from a similar process, I feel for you, man.
Well, I saw someone saying that Google hair plant in Istanbul, being a Turkish company as Volosoft, I know for a fact that we have a lot of tourists coming for hair implants. So if you would like to just Google that.
Ah, Turkish hair plugs. Interesting.
Yeah, that's very common. Okay, well, thank you so much, Todd. It was a great session. I actually forced some people to ask questions, and most of the attendees said you were so clear with your presentation and so fun, actually. They didn't have many questions towards you. So thank you so much. Please be sure to open your free trial on request metrics and ask for that ABP conference discount.
Heck yeah.
Okay. All right. Well, thank you so much, Todd. Now we will hop on to the raffle winners and then we will finish.
Thank you so much, everybody.